How you doing? My name is Arturo Gutierrez, and I'm going to do the video explanation for problem 2, quiz 2. Real quick, Professor, I attached a copy of the quiz on the email where I provided the link to the YouTube video. I ran into a little bit of a hiccup, so I believe I scanned the wrong document, which actually I'm gonna explain here. So starting off the question, based off the given information, the dead load, the live load, I used the load combination provided to calculate the load demand, and then from there I used it to calculate the moment demand, M sub U, so 178 kip per feet. And then using the restrictions of H equals L over 6, H over B in between supposed to equal in between 1.5 to 2.5, I came up with H of 20, B of 10, D of 17, and then I left the 3-inch clearance at the bottom. So as you can see, I misunderstood the question, and I started to calculate everything assuming the balanced ratio, since there wasn't a ratio given in the question. But I then realized that you asked for us to compute the problem based on MU. So then I computed the ratio based on MU. So if you actually scroll over to page 3, that's where the correct calculation using the reinforcement ratio based on MU was used. So I calculated the reinforcement ratio based on MU, the 178. I got a ratio of 0.014. I used that to calculate the amount of steel needed. So ratio times BD, in my case 1017 times 0.014. I got steel needed of 2.39. I went ahead and selected 3 number 9 bars, 1 inch square each, which would give me a total area of steel of 3 inch squared. And then just as you said, I calculated the capacity and substituted D minus A over 2 with 0.9 D. So plugging all that in, I got a capacity of 206.55 kip per feet, which is more than the demand of 178 kip per feet. So the size that we have does work out. Then I went ahead and calculated the clearance at the bottom, and also the spacing in between the bars. So the clearance, I was able to meet standard. I did 3 inches, that's what I left, 3 inches, minus the number 4 stirrup of a 1/2 inch diameter, minus half of a number 9 bar. So I got 1.96, we only need 1.5. So with the spacing, I came up a little bit short. I came up with 0.87 inch, which is a little bit short to meet the standard. I believe I could have expanded my B to a little bit close. I had B of 10. I could have expanded a little bit closer to 13. Reason being is because you said that it could be H over B could be anywhere between 1.5 and 2.5. So I got it right in the middle. H over B equals 2. But I could have expanded my B and got it a little bit closer to 13, which would have still put me at H over B at about 1.53, which would have met that threshold. After that, you asked to go ahead and check our calculations and verify phi. So I went ahead, set tension equal to compression. I calculated A 5.29, and then since we have a PSI of 4,000, B sub 1 is going to be 0.85. So I use that to calculate C, our neutral axis, 6.22. With that, we can calculate the strain, D minus C over C times 0.003. It gave me a strain of 0.051, which is actually equal to the strain in yield plus the 0.003. So this gave us a tension controlled situation, and with the tension controlled section, actually it does correspond to a phi value of 0.9. So I assumed 0.9 when I came up with the capacity, and it was verified, so that is correct. And that is problem 2. Thank you.